Good afternoon. My name is SARHAN Kumar Analalaki Marimuthu and I am from RY40. My metric number is 191382078. So today I am going to give an explanation about an online assessment 1 from the subject PGT213 Analog Electronics. The first question is, to illustrate what an OP-AMP is, we need to consider its ideal characteristics. A. Explain what an ideal OP-AMP. An ideal OMP amplifier is an amplifier with infinite input impedance, infinite open loop gain, zero output impedance, infinite bandwidth, and zero noise. It has a positive and negative input which allows circuits that use feedback to achieve a wide range of function. One of the ideal OP-AMP characteristics were infinite input resistance. The input terminal of an ideal operational amplifier does not have any current to flow in. In electronics, OP-AMP are voltage gain devices. Next is a zero output impedance. The output of an ideal OP-AMP is a perfect voltage source. No matter how the current flowing to the amplifier load changes, the output voltage of the amplifier is always a certain value, that is, the output impedance is zero. This is the ideal OP-AMP symbol and transfer characteristic curve. The transfer characteristics curve has linear region, positive saturation and negative saturation. Another two OP-AMP characteristics were infinite open loop gain. In an open loop state, the differential signal at the input has an infinite voltage gain. This feature makes the operational amplifier very suitable for practical application with upper negative feedback configuration. Next, infinite common mode rejection ratio. An ideal operational amplifier can only respond to the difference between the voltages at both ends of V plus and V minus. In addition, the same part of the two input signal, common mode signal example, will be completely ignored. Question 1b. Distinguish the properties of a LM741 to those of an ideal OP-AMP. An ideal OP-AMP use no power, have infinite input impedance, unlimited gain bandwidth and also slew rate, no input bias current and no input offset. They have unlimited voltage compliance. As for practical OP-AMPs, consume some power, have very high input impedance, have limited gain bandwidth and limited slew rate, have some input bias current and input offset voltage. Voltage compliance is limited by the power supply, rail or frequently even less. This figure illustrates the pin configuration and internal block diagram of IC741 in 8-pin DIP and T058 metal can package. The first pin is offset null, second is inverting input, third non-inverting input, number 4 V negative. As for 5, offset null. Pin number 6 is out, 7 is V positive and 8 is N over C. These were the specification of IC741. Power supply, it requires a minimum voltage of 5 voltage and can withstand up to 18 voltage. Input impedance about 2 ohm. Output impedance about 75 ohm. Voltage gain 200,000 for low frequency, 200 voltage over millivoltage. Maximum output voltage 20 mA. Recommended output load greater than 2 kilo ohm. Output offset ranges between 2 mV and 6 mV. Slew rate 0.5 V. It is the rate at which an OP-AMP can detect voltage changes. Next were question 2. If the OP-AMP were perfect, the ideal step response of OP-AMP will be produced in practical. However, the output is the exponential with a certain time interval. A. Show an OP-AMP with an input voltage step and its resulting output voltage that related to the slew rate. B. Explain what is the slew rate. It is important. And defend your answer. This figure shows the example of operational amplifier which consists V in and V out. V in is 0 to 5 voltage and it's equals to V out. It also shows the slew rate and bandwidth. The slew rate of OP-AMP or any amplifier circuit is the range of change in output voltage caused by a step charge on the input. It is measured as voltage change in the given typical effect of OP and slew rate. This is the input square wave and output limited by slew rate. Next, slew rate distortion. If an OP-AMP is operated above its slew rate limit, signals will become distorted. The easiest way to see this is to look at the example of the sine wave. The maximum rate of the voltage change occurs at the zero crossing point. As for question 2b, what is slew rate? A slew rate is defined as the maximum rate of output voltage change per unit time. It is denoted by the letter S. Uh, if asked as it is important, yes it is. The slew rate helps us to identify the amplitude and maximum input frequency suitable to an operational amplifier, such that the output is not significantly distorted. Question number 3 is, give an example of an inverting amplifier using an OP-AMP with component values and explain A. Where the visual ground is, B. The properties of a visual ground, and C. The closed loop voltage gain and input impedance. As for the position of the virtual ground, a virtual ground is a node of a circuit that is maintained at a steady reference potential without being connected directly to a reference potential. This is the example of the circuit, and the red dot shows the virtual ground. This shows the waveform, and the red line is the visual ground. The value is usually approximately 0. As for the properties of the visual ground is a concept that made for easy explantation and calculation purposes. Voltage is approximately 0, not able to sink infinite current, not electrically connected to ground. As for question C, this is the closed loop voltage gain and the input impedance. The formula of gain is negative Rf over Rin. As for Vout, the formula would be negative Rf over Rin times by Vin. The question 4 is, construct a summing amplifier and summarize the theory of operation. So as you can see, this is the summing amplifier circuit that I construct. The input is connected to the inverting, so the output will invert. This is the waveform shows the invert. 1 voltage invert into negative 2 volts. Summing amplifier is basically an OP-AMP circuit that can combine numbers of input signal to a single output that is weighted sum of the applied inputs. This is the formula of Vout. As you can see, the values of the such as V1 and V2 can be found out in the circuit. As for Vout, negative Rf over R1 times by V1 plus Rf over R2 times V2, concluded with negative Rf over R bracket V1 plus V2 plus the number of V's from the circuit. So that's all for today. Thank you and have a good day.